Hey ANPers, this is Dr. Jones checking in. This is ANP1, Lecture Test 5, Video 9, covering page 11. So for me, this looks like yay, although they don't always print out the same. So we're here. The resting membrane potential, which is what they used to call the transmembrane potential. Now it's the membrane potential, not the transmembrane potential, but it's the same thing. And there are three things that you need to know. There we go. Okay, and number one, I don't see it on the picture here. All right, move me out of the way. Number one is that the cytosol and the extracellular fluid differ in composition. So the cytosol is the intracellular fluid, the fluid inside the cell, and it's made of different stuff than the ECF, the extracellular fluid or interstitial fluid. Mostly the cytosol has proteins in it, and the extracellular fluid should not. There are other differences. We've covered a couple of them briefly. Okay, well, let's cover them. Yeah, let's cover it now. Okay, so here's a cell. The inside of the cell is relatively negative compared to the outside of the cell, negative. And it has a low sodium concentration. I didn't make my cell big enough. Yeah, no, that's not big enough. Try again. Okay, let's eraser this. Yeah, okay, start over. Back to pen. There you go. Relatively negative on the inside, comparatively positive on the outside. And the inside has a low sodium concentration. And of course the brackets are chemistry for concentration. Sodium is Na+, natrium is the Latin word for sodium. So that's why sodium is Na. And it has a high potassium inside the cell compared to outside the cell. Potassium is K+, but I don't remember why. Feel free to Google that and leave it in a comment so that everyone will know. That'd be great. Okay, thanks. All right, and so this is maintained by the sodium-potassium ATPase pump, which burns an ATP to pump 2 potassium in and 3 sodium out. And so that's how we maintain the resting membrane potential, the transmembrane potential of a resting cell. Okay. And that was number one. Number two, cells have selectively permeable membranes. Selectively, what did permeable mean? So permeability is the quality of what is allowed to cross the membrane versus what is not. And so these are selectively permeable. You may recall that freely permeable means that anything can cross the membrane, like an arch without a door. Anything can fit through. Impermeable means nothing can cross it. This would be like a concrete wall that nothing can get through. And selectively permeable would be like our front doors to our houses that have a lock on them. And if you have the key, you can get through. Or if somebody lets you through, you can get through. But not just anybody. Okay. Selectively permeable. And then number three, the membrane permeability varies by ion. All right. Next, passive processes acting on the plasma membrane. So we have talked about diffusion. Okay, so we do expect ions to move down their concentration gradients, absolutely. So if ions move from areas of high concentration to areas of low concentration, which is diffusion. And we know that, white screen, oops, subtitles. Okay, try again. White screen. Okay, here's our cell. And we know that it's relatively negative inside, relatively positive outside. We know that there's a low sodium concentration. Seems like I just drew this. And a high potassium concentration compared to the outside of the cell. So if ions move from an area of high concentration to an area of low concentration, we know that potassium ions are high inside the cell and low outside the cell, potassium ion concentrations. Okay. We would expect the chemical gradient, which is the concentration gradient, to drive it. So if you have a potassium leak channel right here, and of course channels are always in the membrane, so there's a membrane. And we expect potassium to move down its concentration gradient. Every time you open a potassium leak channel, potassium leaks out of the cell. Okay. And since sodium ion concentrations are low inside the cell, and high outside the cell, concentration, sodium ion. Okay, that works. If we open a sodium ion channel in the membrane, sodium is going to go which direction? Well, it's diffusion. It always goes from areas of high concentration to areas of low concentration. If you put crystallite powder in a water bottle, the powder is going to move from areas of high concentration to areas of low concentration. It's going to diffuse around. It's not that like the little bit is going to move up its concentration gradient. It's always going to move down its concentration gradient and spread out. Okay, so we're always going to move down the concentration gradient. Sodium, every time you open a sodium ion channel, sodium, like fools, rush in. Every time, every time, every time. This semester, next semester, in trees, like every time. Okay. All right. So the separation of positive and negative charges is called the potential difference. So this is a potential difference. C. Okay. And it is measured in millivolts. And it is abbreviated lowercase m, capital V, because Volt was the dude's name. Last name Volt. That's why we have volts, because Volt discovered volts. The average resting membrane potential of a neuron is -70 millivolts. And this is the number we're using. If you Google it, you'll see a small range of numbers, and like anything else, there's a within normal limits range of normal. This book uses -70 millivolts. The test questions that I use are largely from the test bank, or I've edited them, or I make up a few. But we are using the -70 millivolts as a resting membrane potential of a neuron. Full stop. Which is what they call a period in British. They're like the end of the sentence, a period, they're like full stop. And that means end of the sentence. Isn't that funny? And they say boot for trunk. It's in the boot of the car. I like collecting Britishisms. It's like the same language, but completely different words. Or they're like the same words with completely different meanings. So much fun. Okay. I tend to collect words though, so that's just the way I am. Positive and negative charges. repel, right? I'm sure I've still got magnets around here somewhere because I'm like that. Every now and then during y'all's tests, when we have them in person, I get bored because your tests in person are boring for me to sit and watch. And so I'll take a magnet and like a paper clip and like in the same direction. You can magnetize it if you rub it with a magnet all in the same direction. It takes a good like 300 times, but then you can like use a paper clip to pick up other paper clips. They're just kind of sticking to it, but not enough to hold it. I'm off topic already. Okay, so same charges. Okay, these electrical charges are not magnets, but the same charges repel, so it's useful. What about opposite charges? So positive and negative charges attract each other. Opposites attract. It's a truism and a really terrible Paula Abdul song. Remember the cat in the video? Oh my criminy, I really don't know what they were thinking. Okay, so the electrochemical gradient is when you combine the chemical gradient and the electrical gradient. The chemical gradient is also the concentration gradient, which is like how much crystallite powder you have in your water, right? So if you accidentally put 2 crystallite powders in the same bottle of water, then you've doubled your chemical gradient, your concentration gradient. Okay. Actually, no, you've doubled your osmolarity. You haven't doubled your concentration gradient. Okay, if you put 2 of them in and they hadn't stirred in yet, that would double it. Okay. So the gradient is the difference. So when you first put it in and there's a whole lot of powder right at the top and absolutely no crystallite at the bottom, then there's a huge gradient. Okay. And the electrical gradient is the difference between the positive and the negative charges. So at resting membrane potential for potassium ions, you have a large chemical gradient pushing out of the cell. I'm going to change colors. I'm feeling blue. So you have a large chemical gradient pushing potassium out of the cell, which we already talked about. But this potassium is positive, and the inside of the cell is negative. So you have a moderate, make it smaller, electrical gradient pulling potassium back into the cell. So when you add a large push out with a small push in, combined, you get a small push out of the cell. So you get a small electrochemical gradient pushing potassium out of the cell. So we just did this paragraph right here, and I drew a large chemical gradient pushing potassium out of the cell. I drew a moderate chemical gradient pushing potassium into the cell. You add them up, you end up with a small electrochemical gradient pushing out of the cell. And now we'll do this one for sodium. I'm feeling green for sodium. It's a nice kind of a neon-y green. Okay, so with sodium, you have a moderate, how big did I draw a moderate arrow? A moderate chemical gradient, so concentration gradient pushing into the cell. And the sodium is positive and the inside of the cell is negative and opposites attract. So we also have a moderate electrical gradient pushing into the cell. So when you add those up, you get a large electrochemical gradient pushing sodium into the cell. So every time you open a sodium ion channel, which is increasing the permeability of sodium, because if you open a sodium channel, you've increased the permeability. Just like if you open a potassium channel, you've increased potassium permeability. So let's go back to our sodium. So anytime you open a sodium ion channel, anytime you've increased sodium permeability, sodium, like fools, rush into the cell because chemical gradient pushes it into the cell, and also the electrical gradient pulls it into the cell at the same time. So you get a large electrochemical gradient pushing sodium into the cell. And that, my friends, was page 11. We will come back in the next video and talk about page 12. Thank you, as always, for tuning in. The education really must go on. You can do it. Hey, let me say this. After everything that has happened in the world with COVID and everything else, and the school and all the other stuff that y'all are juggling, you are still here watching T5 videos in November, and you are still here after everything. You, my friend, are winning. Okay. I'm proud of you. Keep on keeping on. You can do it. Okay. Dr. J out.